Trying this again. Oh god. So we're looking at area and perimeter of regular polygons. So we just need to go ahead and understand what's going on right here. So we just need to know the parts of a polygon given certain things. So we're going to first start with our side. This is a side length. So that's the length of all sides. Now, if it's a regular polygon, all sides are the same, all angles will be the same. You also have the center, which is right here. It's right there. And then we also have a radius. And that's because if we circumscribe this within a circle, all these vertices would touch the edge of the circle. And so therefore, all these lengths from here, from the center to the vertices, are all going to be the same. So that means that we have a whole bunch of radii. Okay, so all of them radius. And then we have the apothem. The apothem is the distance from the center to any of the sides on a regular polygon. So of course we have a regular polygon, all the sides. What are the sum of the interior angles of a regular hexagon? So we have 180 times, 6 minus 2, which would be 720. Now, if you take the number of sides and divide that by, take 720 divided by the number of sides, that gives you 120. So that means that this side right here, this angle right here is 120 degrees. But what happens is that 120 degrees gets bisected by each of the radii. So this becomes 60 degrees. So all this is 60. And of course, if you cut that into two equal parts based off of that apothem, that gives you a 30, 60, 90 triangle. Now we're going to be using that primarily to go ahead and get our information on these particular pieces of stuff. Now, the area of a polygon is given by this formula. So it's 1/2 the apothem times the perimeter, or AP divided by 2. So we're going to have to find out what our apothem is and also what our perimeter is. That's not going to be too difficult, especially with the fact that this is a 30, 60, 90 triangle. This being 30, 60, 90, that means that this side length is half of whatever this hypotenuse is. So this is 6. And the height, the apothem, is equal to 6 times the square root of 3. So the apothem is 6 square root 3. Also, since these two sides right here are the same, that gives me a side length of 12 because it's going to be equilateral triangles. So this is 12, 12. And of course, you can go ahead and do the math right here. So 6 times 12, sorry. Thinking too big. So that gives me a perimeter of 72. So now, when we go ahead and get our area, that's going to be 6 square root 3. Times 72 divided by 2. And I got somebody here, so just hold on. Had to tell a student that today was A day, not B day. So we're going to take 6 times 72 divided by 2. 6 times 72 divided by 2. That gives us 216. So 216 times the square root of 3. 216 square root 3. Okay. Same thing over here. This is going to be 5 square root 3. And then, of course, all the side lengths are 10. Basically, this is equilateral triangle, so all of them are going to be 10. So it's going to be 6 times 10 to get the perimeter. So that's 60. And the apothem, of course, is equal to 5 square root 3. So 60 times 5 square root 3 divided by 2. I actually know this one on top of my head. So 60 divided by 2 is 30, and multiply that, that's 150 square root 3. So our area is 150 square root 3. Whoops. Square root 3. Sheesh. It's not behaving. Another example, just to go ahead and do this for the heck of it. So this is half of 24, that's just 12. And then this is going to be just 12 times the square root 3. So our apothem, 12 square root 3. The perimeter is equal to 24 times 6. I'm going to do that real quick over here on my calculator. So let me see, 24 times 6 divided by 2, which is 72. Don't know why it's doing that. It's just acting up. Okay, so area is going to be equal to 12 square root 3 times 72. God, I hate this thing. It's not 70, it's 72. Ah, got it. I hate you. Okay, so it's 72. And divide that by 2. So 12 times 72 divided by 2, that gives us 432. And remember, we leave the square root 3 out of the calculations, and that's going to be your exact answer. 432 square root 3. Okay, so same thing over here. I don't like these problems because it's actually easier just to do it another way. Okay, so I'm just going to go ahead and show you this right here. Sum of the interior angles, of course, you know that's 360. And of course, if you take 360 divided by 4, that gives you 90. And the special right triangle, well, if I go ahead and do this right here, this is a 45, 45, 90. But we're not going to concentrate on that. We're not going to use that very much. 45, 45, 90. Okay. Okay, so here's the exact area. We're going to do this as simply as possible. Okay, so, hey, look at this right here. The apothem is 9, but the apothem is half of the side length. Hey, side length is 18. And this is a square, so both sides are the same. So it's 18 squared. That's equal to our area. So 324 units squared. Hey, this one's 10. Oh, wait a minute. We have a diagonal, and I'm going to tell you this. This is also a rhombus. So the area formula for a rhombus applies to this. So this is area is equal to diagonal 1 times diagonal 2 divided by 2. So this is going to be, let's see, this diagonal is 20, and they're both the same. So it's 20 times 20 divided by 2. Which gives you 100 inches squared. And that's your answer. Same deal here. Except now we have 3 squared, square root 2. So this gives me 6 square root 2. So area is equal to 6 square root 2 times 6 square root 2. Divide that by 2. So 6 times 6 is 36. Square root of 2 times square root of 2 is 2, and then divide that by 2. These two cancel, so 36 meters squared. You could also use the fact that this is a small 45, 45, 90. You take 3 square root of 2 divided by 2, square root of 2, that gives you 3. Hey, this side is going to be a total of 6 by 6. 6 times 6, 36. I'm not going to let that bother me. Now, remember, all radii are the same. All the radiuses are the same. So this right here is actually 14. Now, here's a bigger thing. This is a 30, 60, 90 triangle. Not 35, 30, 60. So, therefore, the apothem is half of the hypotenuse, which is 7. And this is 7 square root 3. Well, since both of these are the same, that gives me a base distance of 14 square root 3. So, I'm going to treat this like a triangle. Okay, the height right here happens to be 14 plus 7, which is 21. Okay, area of this triangle is 14 plus 7, which is 21, times the base, which is 14 square root 3, divided by 2. So, 21 times 14 square root 3 divided by 2. Actually, don't multiply by the square root of 3. Leave that out. That's going to be 147 times the square root of 3. And that's your area. This length is 10. Remember that the apothem is half of whatever that hypotenuse is of this small right triangle. So this is 5. And then you got this, they got 5 square root 3. So that gives us a side length of 10 square root 3. So we just take 10 plus 5, well that's 15. So we have 15 times 10 square root 3, base times height divided by 2. So we have 15 times 10 divided by 2, 75 square root 3. And that's it, we're done.